All right, let's get ready to experience some joyful, uplifting, and exciting mathematics. But we are going to start at the very beginning. We're going to assume that we know nothing. We're going to learn how to count. You're thinking, hey, I know how to count. Well, I want you to forget anything you know. Sit back and just enjoy yourself. Let's get ready for exploding dots. Without further ado, here's the man behind exploding dots, James Tanton.
This begins with a story that's not true. I've already told you a story that's true, now let's tell you a story that's not true.
Not true.
When I was a child, I invented a machine. Not true. And all my machine was a row of boxes. Like that. And they could go as far to the left as ever I desired. And being a strange child, I gave this machine a strange name. I called it a 2-1 machine. Written in a funny backwards way. When I'm a young child, I know it's different. And the idea of this machine is you put in dots. So dots will go into these boxes. If I've got one dot, is one dot, always goes to the rightmost box. Zoom. It's not very exciting, it just stays as one dot. However, if you put in a second dot, always the rightmost box, zoom. Here's what happens. Whenever there are two dots in a box, they explode. Kaboom! And are replaced by one dot, one place to the left.
All right, so we have a row of boxes. And we count dots always in that first box. And we only have one rule. The only rule is when you have two dots in any box, those dots explode and become one dot, one space to the left. Now we're going to play around and we're going to create a code for numbers. So we started out with one dot. Well, one dot is 1. Two dots.
Hence the name 2-1 machine.
Is going to be.
All right. So now 2 dots looks like nothing, 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 nothing.
1,
dot, 0.
0.
So now I write the code for 2 is now 1, nothing, 1, 0. Here comes the third dot. Always the rightmost box. Zoom. So what's the code for 3 in this machine? 1, 1. I have a feeling a fourth dot's going to be particularly exciting. Here goes. You ready for it? Zoom. Kaboom.
Boom.
Dot.
Oh. Kaboom.
Dot. So what's the code for 4? 1, 0, 0. What's the code for 5 going to be? Can you see in your mind's eye? 1, 0, 1. What's 6 going to be? Okay, 5 you tell me is 1, 0, 1. That's 5. Here comes 6. Zoom. Kaboom. Dot. 1, 1, 0. What's 13? I skipped some numbers. Okay, seriously. I believe you have pencil and paper, don't you? What's 13? What's the code for 13 in this 2-1 machine? 1, 1, 1? 1, 1, 0, 1? 0? 0, 1, 1. 1, 1, 0, 1. 1, 1, 0, 1. 1, 1, 0, 0, 1, 1. 1, 1, 0, 0, 1, 1. 1, 1, 0, 0, 1, 1. 0, 0, 1, 1.
Here that we can play around in our 2-to-1 machine. We can count for as long as we want. We can create codes for basically any number that we can count to in our 2-to-1 machine. But then wait a minute. We're playing around as a kid and we're saying, wait a minute, we can definitely change the rules here. How about instead of doing a 2-to-1 machine, maybe we do a 3-to-1 machine? Then what happens?
So how would that one work? 3 dots in a box, they explode, become one place left. Okay, brilliant. Put in 1 dot. Zoom. Not very exciting, stays as
1 is 1.
Put in a second dot.
2 dots. Well.
Not very exciting, stays as 2 dots. Put in a third dot, however.
Ooh.
Zoom. Kaboom. Dot. 1, 0. Fourth dot.
4.
Zoom.
1, 1.
Fifth dot.
1,
1,
2.
2. Sixth dot.
Ooh.
2, 0. Zoom. Dot. 2, 0.
What about 13?
13.
We can play around in our 3-to-1 machine the same way we did in our 2-to-1 machine and create a bunch of code for numbers. But wait a minute. What if we did a 4-to-1 machine or a 5-to-1 machine or
4-1 or a 5-1? Let's go crazy. Let's go all the way up to a 10-1 machine.
Whoa.
Whoa. In fact, let's put in 273 dots in a 10-1
Whoa.
machine. Let's go crazy.
Baby.
What is the code, the secret code for 273 in a 10-1 machine? I think you guys are on to me. All right. But I'm in my untrue story. I'm still a young child here, so I'm actually going to do it. I'm going to put in 273 dots. Here goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I don't know my watch. Tell me when I've got enough. Is that 273 yet? Excellent, excellent. Okay, I'm slow. I'm going to ask you yes, no question. Will there be any explosions? Yes. All right, right off the bat, how many explosions will there be? 27 explosions right off the bat, is that right? Because 10 explode to become 1. So in 273 dots, there'll be 27 explosions. Any dots left behind? 3 dots left behind. So I'll draw the 3 dots left behind. 1, 2, 3. And 27 explosions, each make a dots. How many dots do I get in here? Can I just write 27 instead of drawing the dots? Is that okay? Right, next. Any more explosions right now?
Boom,
Any more
kaboom.
explosions? 2 more explosions. Any dots left behind? All right, 7 dots left behind. 2 explosions, each make a dot. Boom, boom. So what's the secret code for 273 in a 10-1 machine? 2 dots, 7 dots, 3 dots. All right, you're on to me. What's really going on? What are these machines actually doing? Place value? Different bases? Okay, we've got different language here. All right. So let's look at this. Let's go back to the 2-1 machine. So I set this game up. So the dots here are always worth 1. 1 dot, 1 dot, 1 dot. But in this machine, whenever there are 2 dots in here, 2 1s, they go kaboom, and equivalent to 1 dot here. So this dot here must be worth 2 1s. 2 1s is 2. 2 dots here, 2 2s, makes one of these. So this dot better be worth 4. 2 of these makes one of them. So this dot here is worth 8. 2 4s. 2 of these makes one of thems. 2 of themses makes one of thoses. 2 of thoses makes one of the nexuses. 2 of thems makes the next one. 128. Tell me when you want to stop. Next 2 of those makes the next one. 56. Are you getting bored yet? Stop there. All right. You told me at least twice that 13 was 1 1 0 1. You said 1 dot, 1 dot, 0 dots, 1 dot. Can you now see that you were right? You told me 13 is 1 8, 1 4, no 2s, and 1 1. Can you now actually see it? Bingo. Welcome to base 2.
We can see that the way we counted in base 2, the way we counted in base 3, or in base 4, or in base 5, or in base anything, is exactly the same way that we count in base 10.
I heard both answers then. 3 3s, 9. 3 of
Is
those makes
exactly
one
the
of them's.
same as we
3 of them's
count
makes one
in
of
base
thoses.
10.
Do you want to keep going or
Let
not?
that sink in for a
Good
minute.
answer. You told me 13. At least 2 people said 13 was 1 dot, 1 dot, 1 dot. Were they right or were they wrong? Absolutely right. 1 9, 1 3, 1 1 does indeed make 13. And so in a 10-1 machine, same idea. These dots are always worth 1. 10 of those makes one of them, so that may be worth 10 1s. 10 of these makes one of those, that may be worth 10
There is
10s.
nothing special.
100.
What
10
I'm
of
trying to
those makes
get
one of
through here
thems.
is there is nothing special about this 10 to 1 machine. There is nothing special about how we count in base 10.
Alright. In fact, it's kind of curious. That's our code.
And it's actually, I mean, it could make a lot more sense to count in base 2.
200.
You know, we have 10 fingers, is probably why we use base 10.
3.
You know, and our whole language is base 10.
200,
but,
7 T's.
you know.
What's TY short for? Actually short for 10.
I might say that any base is really base 10, base 1, 0, because whatever base you're in, you don't have that digit in that base. There is no number 10.
So that begs a question then.
There's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that is it.
We are so familiar with the number 10 with counting. We often associate, we think 10 is very natural to us for counting. Though there are some cultures that are base 20 instead. Where's that coming from? Base fingers and toes. All right. So there are vestiges of base 20 still in our Western society. I happen to be in the US right now. How does the Gettysburg Address begin? 407 years ago. How many years ago is that actually? 407. A score is an old word for 20 years. So he's literally, Abraham Lincoln was actually speaking base 20 there, 4 20s and 7 years ago. Who speaks French in this room? Okay. How do you say 87 in French? 87. Word for word, that again is base 20. They're saying 4 20s and 7. There are some cultures that are base 12. They're very used to counting to 12 on their bodies. I'm serious. A lot of Southeast Asia, a lot of India, still doing it to this day. How do I get 12? Why is 12 natural to a lot of people? So actually, think of one hand as a very natural way to count to 12 with one hand. You've got 4 fingers, each broken into 3 sections, and a natural pointer, your thumb. They count this way: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are a lot of cultures that are actually base 12, probably because of this.
So as I'm starting to run kind of low on time here, I think I'm going to leave it right here. But what we just saw and experienced is just the very, very, very beginning of Exploding Dots and what Exploding Dots can do, and the understanding that Exploding Dots can bring to ideas that might be very complicated, or ideas that maybe you thought you understood, but in reality maybe you really didn't have a understanding of these ideas. But I also created, before I did this screencast, a ThinkLink where I have I have the entire presentation of this presentation by James Tanton, but also many others of his shorter lessons, where Exploding Dots is not just about converting to different bases and learning to count in different bases. And again, we can see that what we can do in any base very easily, because again, any base is just the same as base 10. But everything, let's just say we stick in base 10. Exploding Dots can take you through pretty much everything you do in school. Starting out early grade school, you learn first how to count, and then how to do addition, subtraction, multiplication, division. Why do you always have to go from right to left when you add and subtract? And then division, sometimes you do left to right. Well, the liberating answer here is you do not have to do it that way. And then we can go and say, well, let's just not do base 2, base 3, base 4, base 10. How about we do every base at once and go into advanced high school algebra, polynomial long division, which is exactly the same as we learn in early grade school. And then we can go on and do calculus, infinite series, with the same Exploding Dots. This same exact idea can take us to calculus and then to unsolved research problems. Unsolved problems that are still baffling mathematicians to this day with this same idea of Exploding Dots. It is truly one of the most mind-blowing ideas and experiences that has come along that I've ever experienced with mathematics, and it truly is a joyful experience when you have this true understanding of an idea and you make it your own, and It's amazing.